Given tangent of theta equals 5 over 6, sketch a triangle that has acute angle theta and find other 5 trigonometric ratios of theta. Because tangent of theta is opposites over adjacent in a right triangle, so we simply draw a generic right triangle with an acute angle theta. Tangent of theta, by definition, is the opposite side over the adjacent side. So, for convenience, we would label the opposite side to this angle theta 5 and the adjacent side 6. From this, we can also find the hypotenuse. This is the right triangle, so the hypotenuse squared equals 5 squared plus 6 squared, or 61. The hypotenuse is therefore square root of 61. We cannot simplify the square root of 61, so we would leave it as square root of 61. We're done with sketching the triangle, and in this case, it is a right triangle. Find the other 5 trigonometric ratios of theta. Sine of theta is the opposite 5 over the hypotenuse, which we found the square root of 61. Cosine of theta is the adjacent side 6 over the hypotenuse, square root of 61. And we double check tangent of theta using this right triangle. Tangent is the opposite over adjacent as given. We then proceed to find the 3 reciprocals of sine, cosine, and tangent. The reciprocal of sine is cosecant, so cosecant of theta equals the square root of 61 over 5. Cotangent of theta has the reciprocal secant theta, so secant of theta is the square root of 61 over 6. And cotangent of theta is the reciprocal of tangent of theta, so cotangent of theta is 6 over 5. One more thing. We will need to simplify 5 over the square root of 61 for sine. 5 over the square root of 61 is 5 square root of 61 over 61. 6 over the square root of 61 is 6 times the square root of 61 over 61. Now, we didn't want to simplify it because if we were to use this expression for the reciprocal, we would have to simplify it again. Recall that to simplify 5 over the square root of 61, we simply multiply the square root of 61 over the square root of 61 to get 5 times the square root of 61 over the square root of 61 squared is 61.